right. We are ready for more 4coder Friday now. So let's see. I just left off with some very simple final touches to this thing, if I remember correctly. We're filling this. We need to set a variable here. So here I'm going to call, let's see, I'm going to stop putting every variable into the framework and start doing this. Sticky jump marker handle var sticky jump marker handle lock. And then what we're going to do is we're going to come down here and call the new API managed variable create or get ID. App sticky jump marker handle var default value is 0, location sticky jump marker handle lock or loc. Alright, now what? I've got a variable. I want to set that dynamic variable. Here's the scope I am interested in. Here is the location. And the value is put her as int marker handle. Oh wait, do I have a handle as int? Yeah, there we go. Alright, I think that all looks good. Just thinking, double thinking everything, but I think we're good. Double thinking through everything, I should say. Okay, finally, we get that managed memory allocated, and so then I want to do managed memory oh, I haven't written this API yet, right. Managed memory set here's the managed object, and then manage memory set that to let's see, we'll start from 0, this much, and stored. Okay, so what have we done? We grab the buffer with the jump list, we parse out the jumps, we get them in an array right here. We group the jumps together by consecutive repetitions of the same buffer, destination buffer. We then sort that set of ranges so that every range of the same buffer is contiguous in the sorted version, and we make a set of ranges over the ranges, or an array of ranges over the ranges, so that now each buffer has one range that goes over the ranges that go over the jumps that are for that buffer. We may then allocate, knowing how many jumps we need, all of the stored jump memory that we're going to fill, and we start visiting all of those ranges one at a time. For each of those ranges, we get a target buffer count, or target buffer ID, the total count of jumps in that buffer, or into that buffer, and we fill an array of markers. We then set that array of markers as a set onto the target buffer, and then we set a variable in the scope that we get by intersecting the target buffer with the list buffer. We set a variable that refers us to that marker handle. Then we finally, once we've done that for all of the buffers, we'll also have filled all the stored memory, and so then we allocate the stored memory onto the scope for just the list buffer, and we set it, and then we're done. That looks good. We want to get down to the point now where the only build errors are for the missing API. Got light on my face again, like every time. I've almost managed to get all the light out of the room, but there's still this little sliver of light that bothers me every 4coder Friday. Alright, let's see. Total count. Okay. I can either choose to make that a const char star, or I can do the right thing and take the const off of this. Alright, so that's just a failure of the API, and then this is the follow-up stuff that uses the system to do the jumping. Alright, so we got to implement the API, and then before that I'm going to go through all this and get everything else fixed up. Alright, so let's take a look at what a marker list is, what it comes from, etc. Yeah, I probably should invest in like some blackout curtains for my windows, because they are a source of trouble. I also have a fan in here that I got recently to help with the heat. I might turn that on in a minute. So I'm trying to track down, okay, a init marker list. Do we actually do anything with the list anymore? No, we don't. So this inits a marker list without actually initting the marker list, which is a problem. It's annoying. I'm not sure. Okay, let's take a look at where this gets called. So we get our make list for buffer, and what happens is we get marker list for buffer. I believe that just does an iteration, and if the node has a buffer ID matching the buffer ID we're looking for, then we return that node. Otherwise, we return 0. And then what? If the thing we got was not 0, then we check the previous size against the buffer size, and if they're not the same, we delete the marker list and set it to 0. Then, if it is 0, we make a new list for the buffer, and we initialize it here. So whenever we do that init marker list, that's all we have to do to make this work, is set the list's previous size to buffer.size, I believe. Okay. So then, what is this problem? So the list used to keep its own jump count, and that's gone. Why is that gone? It probably shouldn't be gone, right? Later, Dave. Thanks for stopping by. Okay. Alright, so this part is where I question. The marker list can actually be eliminated, but I'm not going to jump straight into that. For now, what we'll do is we're just storing these. What exactly is it looking for there? First jump index. Yeah, none of that really applies anymore. We're looking for just this index. Okay, so the way this needs to work is, in addition to all this, we're going to get a scratch memory. And then we're going to put some temp marker in there. And then we're going to say, grab the... Actually, we don't even need that. Oh, nice. Nice. Okay. What we can do is just say, here's the stored thing we're looking up. Managed memory get. And that's going to look like this. We put in the app. We want to put in the... So we grab the managed object, we set its memory, and then we put it into that list. Then later, we can pull it back out of that list, and we shouldn't actually be storing a managed object into a user's local memory. What we should be doing is storing it into a managed variable so that it will only, so we don't end up holding on to a handle that has gone bad, but we can't do that yet. So, because I'm keeping the marker list around. So once I'm eliminating the marker list, what will happen is this will be gonzo. These will be stored in variables or into a managed object, like a part of the managed array, like the jump array as well. Like these might just be a part of this array. And then I will have a single variable referencing all of that. Sorry, I'm looking at my face on the OBS and playing with that light for some reason. I don't know why I'm bothering to goof around with it. It's just interesting looking. Okay. So, maybe I could actually switch to standing. Let's try that. I've never streamed standing before. This will be an experiment. Okay, the light's a little better now. I mean, that's why it doesn't usually bother me, is I just switch when I'm here without the stream on. So it never becomes a problem except in stream. But anyway, let me adjust the camera too. Alright, so let's take a look now. We want to get the memory out of the list's jump array. I want to start there. I want to go for the size of stored, and I want to unload that data into the struct here. Alright, so that gave me the stored slot right there. Alright, so I get the managed memory. I read from the managed memory that thing there. Let's put that in an if just in case. And then what? So the next thing is I want to figure out if the destination buffer, so I'm going to get a buffer ID from the store target buffer ID from the store jump buffer ID. Then if I'm going to need an intersected scope. So there's the target buffer ID, and then there's the list buffer ID. And with those two I can get the intersected scope Alright, so that gives me the scope that exists when both of these buffers exist. And uniquely keyed by that, I can now look up the variable Okay, so we look up that variable and we're trying to read it, so we're going to have a trying to get those. If we manage to get the markers, then the next thing we want, or the marker array or something like that. Okay, so we get that variable, we get that managed object handle back from the variable, and then we use the same scope again. Well, we don't really use a scope. This lives in the same scope incidentally, but we have the handle to it. We now can do buffer get markers app buffer marker array. Then there's which marker do we want to get. That exists in the stored.index into marker array. There's one of them, and there it is. Okay, so that's how we are getting the marker. Then we can finally return our result. So the location buffer ID equals the target buffer ID, and the location position is the marker position, and result equals true. Okay, so there we go. So how does this work? Double check everything. We get an index coming in, we compare that against the list, which had a jump count set right here when it was initialized. Then if the index is in range, we go ahead and try to get... Okay, this isn't quite right. This should be at the index times size of stored. We want to index into this thing. We're not just reading the first thing off of this array, this managed memory. We want to go into it and get this index. If that succeeds, which by the way means we could actually do this, because if the index is out of range, this will fail anyway. So if that succeeds, then we successfully got something out of the spot we thought we should get something. Let's go ahead and assume that we got the thing we thought we should get. And then we build this intersected scope. We use the intersected scope to get a variable which happens to reference us into a marker array because we set it up to do so right here. The jump marker handle location got sent to a marker handle that was an add markers result right there. And this right here, we're getting the marker array out of jump marker handle. Okay. Then we can read that marker, and that gives us a position, and then we're done. So this is basically give you an index, read into a managed buffer to get from a managed buffer to get the stored sticky jump, intersect some scopes, read into a variable block to get a handle, read from that handle the marker that we want. In total, something like 1, 2, 3, yeah, like 5, 1, 2, 3, well, 4 major operations with the core to do that. Which is pretty good. I mean, it is a double indexed kind of thing. We index into an array which indexes into another array. So there's already going to be like 2 stages of work, and there's just a little bit more work because we have to do this through the managed stuff. Okay. alloc memory set, managed memory get is the next thing it complains about. Now it doesn't have a buffer. That's right, because get markers doesn't use buffers anymore. It just uses the memory object, the managed object itself. Get index exact from list. So you pass in a line, and it's supposed to tell you okay, so to do that, what we're going to need is we're going to need to read in the entire array. Okay, so we allocate an array. If we actually got as much memory as we needed, then we're going to attempt to read it. and we read it into that array that we just got. Then we can do this binary search business. So instead of doing it on that, we're doing it on stored list line, size of stored, jump count, and there's the line we're looking for. So that gives us input a line. We binary search the jumps, which are the jumps stay in order in the stored array, so that the first index the first jump has index 0, the second jump has index 1, and the nth jump has index n-1, etc. And the lines will be in sorted order because of that, making it binary searchable. We put in a jump, and we say, we put in a line and we say, give me an index if we find one that matches. So the exact part is just saying if the line number does not exactly match. Like if you do a binary search on this and the nearest jump has a line number other than the one we asked for, then it's not an exact lookup and so fail. We want to get something on this line. If nothing is on this line, then do nothing or return -1. This is probably for something like if you're like clicking right here and trying to press enter to jump, it like doesn't want to seek to the nearest. It just looks to see the line it's on and it either hits or it misses. So that's an exact. Then the nearest version is this one here. This will fail for similar reasons, but what we can do is, why don't we implement one of these in terms of the other one, right? So we're going to grab that, and then we're going to say there is no extra check on this one. We grab the jump index, that's our result, period, no extra thinking, return it. Then this one can just be get index nearest from list app scratch list line if the result does not equal -1, result does not equal -1, and oh shoot, this doesn't work. This doesn't work because you still need that okay. Okay, so this one does that work, and then what'll happen is before we close the memory for the stored array, we can optionally do this check right here. There we go. Let's see what the compiler has to say. Alloc, set, get. Yep, we'll get those done. Alright, what is this? You don't like right. Stored jump index. Dot list line equals the line. Then we can return that. Okay, get line from list. So now what happens is I put in an index and it just wants to read back the line at that position. Okay, I have a new idea. Okay, so the idea here is I pass in the arena and the list and I want to pull out the array, and I set a restore point because I may want to clear what I allocated because I failed to get the array for some reason. But then I try to read out the array, and if I successfully got the thing I was looking for, I will return that still on the arena. If I didn't get it, I will clear out the arena and return 0. Okay? And then instead of this, what we can do is we can go back to splitting these out, and so this does not run the exact check. This does run the exact check, and that's just that. But this part doesn't have to look like this. It can look like you're gone, by the way. It can look like this. We grab the array, and so the most heavily duplicated part is just gone. If we got stored does not equal 0, we control the temp now, so that memory will still be cleared, and then we grab, yeah, so now we have enough horizontal line space to do this. Okay, so that's how this one will want to look too, except that it wants this thing. Okay. Okay, so that looks good to me. It looks a little bit duplicated between those two still, but the part that I was worried about duplicating has been taken care of. That much duplication is okay with me. Now I can deal with this. So what we want to do is, again, we're going to put down these guys, right there. Begin attempt, grab the stored array. If that is non-zero, then, uh-oh. Don't want to lose what this is actually supposed to do. So, it's supposed to do something like this. Oh, this doesn't need to get a full array anyway. Alright, so all this needs is app and not a scratch. We don't need this, we don't need this, we don't need this. So stored. App list jump array index times the size of stored, and then that stored structure there. If we get that, then set the result to that. Okay, that's pretty straightforward. Okay, manage memory 4 times and then an arena. Manage memory get does not exist. Get index exact from list. We just need to pass in app and part now. 1, 2, 3, 4, 5. And then we're to the new errors. Okay. Okay, here where I'm reading something out of the jumps array again. What is that? I'm reading that. Okay, why don't I do this? Alright, so this is basically going to be one of these, except that we don't do all of this work here. We just do that. And then what we can do is say if we can get the sticky jump stored from the list, then we won't need this call anymore. Okay, so now I grab a stored off of the list and I do all this extra work here. Now this one here is actually just going to be another one of those. Okay, that's nice and simple. And then there's this thing about flags. I'm not sure what that means, but what it really wants to do is check if it is a subjump. So, okay. Okay, go to next filter jump. So the point is now what we want to do is we want to do get index nearest get is sub error from list, which will just be app list index. We're getting very close now. Get line from list. Free marker list. We're going to be trying to eliminate that hook. Now it's going weird here. Alright, I'm going to try to sit down. My legs are getting a little tired. Okay. Not familiar with the put or chook table, but I think that's just because it's got a new name. Yeah. Guess I never finished this pointer check stuff either. So okay, let's see. That should be keys, I think. Alright, now what? Um, Okay, why is it if k is greater than 1? Weird, right? Hmm. Alright, so this is some kind of macro that no longer works because there's no longer a rounded user data size. Oh, yikes. That's not a pretty macro at all. There we go, that's how it's supposed to look. Now we're in the land of virtual whitespace disablement. Man, the editor sucks when it doesn't have virtual white space. Perfect. Okay, so now the only thing preventing us from compiling are those three functions that haven't been implemented, which is where we want to be when we're implementing new API features. We've got everything else back to sort of fitting together. I need a break though. I've been, besides like a 5-minute break, I've been going for 3 straight hours. My brain is liquefying, it feels like, perhaps. So I'm going to cut this one off and take a longer break. Maybe a dinner type situation will occur, and then I'll be back later to get this finished. We're going to at least get the sticky jumps back by the end of the day is the plan. So see you again in like an hour or so. Later.